For this lecture, we are given a set of 5 points. We are to find the polynomial of smallest degree that passes through all the points shown below. Because the x-coordinates of the points are all different, this polynomial of smallest degree exists and is unique. Let the polynomial function be given by f of x equals a sub 0 plus a sub 1 times x to the first power all the way through a sub n times x to the nth power. Here, a sub 0, a sub 1, all the way through a sub n are the unknown constants that we will solve for. Let us label the points as p sub 0, p sub 1, p sub 2, p sub 3, and p sub 4. There really is no order in which we can label the points, at least for the method that we will use to solve for the unknowns. But at least by starting the labeling at p sub 0 and ending at p sub 4, we know that n is equal to 4, which means that the degree of the polynomial cannot be greater than 4. By plugging in the different x and y coordinates into our function, we should be able to get a system of equations for the unknowns. For this problem, we will write out the system as a matrix system. Here is the vector of unknowns whose components are a sub 0 through a sub 4. The coefficient matrix is this well-known matrix. The entries of this matrix are formed by using the different x-coordinates of our points. Multiplying the matrix to the vector of unknowns gives us the different y-coordinates. The coefficient matrix, which is called the van der Waals matrix, is invertible. Its inverse exists. And so all we have to do is to multiply this matrix equation by the inverse of the coefficient matrix to get our vector of unknowns. And this is equal to the inverse of the van der Waals matrix, where we've already plugged in the different x-coordinates and then multiplied by the vector of y-coordinates. And the result is this vector of constants. Extracting the different components of this vector to get f of x is equal to 5.975 minus 6.350 times x plus 4.736 times x squared minus 1.366 x cubed plus 0.1324 times x to the fourth power.